Okay, quadratic equations again, section 1-4, day 2. So far we have done what types of methods for solving quadratic equations? Let's see, we have done extracting square roots, completing the square, factoring, and we've got a couple more that we're going to look at today, okay, for solving our quadratic equations. So the first one, quadratic formula. And let's just derive where the quadratic formula is coming from by completing the square on, right, a quadratic equation in standard form. With everything moved over, it's set equal to 0, so ax squared plus bx plus c equals 0. No, I'm never going to test you on being able to derive this formula, but this will really tell you if you understand your fractions and if you really understand completing the square. Okay, so even if you want to try it yourself first, you're welcome to do that. Okay. All right, so first things first, we said we cannot complete the square unless the coefficient on x squared, the coefficient for x squared is a 1. So just like we did in some of those problems previously, I'm going to factor the a out of the first two terms with the x's in them. And factoring out an a would make that plus b over a times x plus blank equals, remember we're always going to move that constant out of the way, move it to the other side. So we're going to have negative c plus blank. Okay, completing the square then. Completing the square. Well, if I just kind of do a side note here so you know what I'm doing. If I take the b over a, the coefficient in front of x, I divide by 2, which means now it's b over 2a, and then I square it, you should be thinking that would be b squared over 4a squared. Okay, so I'm adding b squared over 4a squared. Again, we need to balance the other side. So what are you really adding to this side? Well, if you think about distributing the a to this, one of the a's would cancel. So what you really added to that side is really just b squared over 4a. Okay, so over here is going to be b squared over 4a. Okay, so next, we said the magic number, if you will, is when you divide by 2 for that middle coefficient on x, is what should go into your perfect square. So we should get the b over 2a, and you could check it for yourself. Put that down, multiply it out, see if you do get the above. Okay, equals the opposite of c plus b squared over 4a. Okay, at this point, go ahead and isolate the x term, if you will, or the squared term. So we want to take what's on the right-hand side without trying to show too many steps at once. Okay, divide by the a. And dividing by a over 1 is the same as multiplying by the reciprocal of 1 over a. So I'll do a couple things at once. We'll take the left-hand side, leave it alone, squared. Right-hand side, let's get a common denominator for our numerator. Okay, so common denominator is going to be 4a. So I'll have negative 4ac over 4a plus b squared over 4a. And I said I'm going to multiply that by the reciprocal of the denominator, so times 1 over a. All right, so then if we go ahead and clean it up a little bit, left side says x plus b over 2a, quantity squared, equals, let's just write this in a different order that you're used to. Okay, that you're used to. So 1, I'm going to go ahead and say, yeah, I know the denominator here is going to be 4a. But if I go ahead and multiply it by this a that's sitting right here, okay, I can see that it's going to be 4a squared. And if I combine these terms and just put them in a different order, I'm just going to put b squared minus 4ac instead of negative 4ac plus b squared. Times 1 is still going to be that. And at this point, you're ready to, you've completed the square, you're now ready to extract square roots. So if you go to the extracting part, put in the square root of both sides. Left-hand side is going to become x plus b over 2a equals, don't forget, right-hand side, you put in the square root, therefore you've got to remember plus or minus. Let's make it the square root of the top over the square root of the bottom separately. So the square root of b squared minus 4ac all over the square root of 4a squared is 2a. And now you're to the point of subtracting b over 2a plus or minus square root of b squared minus 4ac over 2a. And if you combine them, right, so that they're one fraction, you're going to be right here at the quadratic formula. Okay, so definitely you want to have memorized, whether you know how to complete the square to get there or not, you want to have memorized your quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Please don't forget this. It's going to be coming up, but this part under the square root is what's called the discriminant. Okay. Anytime you've got something under a root, that is called your discriminant, and we will be using that in our next part of the notes. All right, so anyway, solutions of a quadratic equation. So the number of solutions depends on that discriminant. And how and why? Well, I really want you to just understand the math when you get there. Okay, I'm not really into you guys just memorizing things, but if you're somebody who really wants to memorize something, I'll put this up here for you. But I really want you to understand why, and we'll refer to that when we go back and do problems. So there's that discriminant, b squared minus 4ac that we were talking about. Now, hopefully it makes sense that if b squared minus 4ac is positive, then you'd have two distinct solutions, right? Because you'd have something like 5 plus or minus 3 over 2, if I'm just making up something. If b squared minus 4ac is less than 0, well, that means you're taking the square root of a negative. So hope you would be in agreement that you get no real solutions. And the last option, what if b squared minus 4ac equals 0? Well, you might be thinking, well, that'd be like negative 5 plus or minus 0 all over 2. So you're going to get the same answer. However, it's a quadratic. And we know a quadratic has to have two solutions, right? So what that means to you is it's one solution, but it's repeated. And that's called a double root that we've talked about before. Okay, and we will talk about that when we get to it in the examples. Okay, double root. All right, let's do some examples together. I highly suggest when you're doing these problems that you just go ahead and figure out your A, B, and C. That seems to help people first. So 1, make sure it's set equal to 0. It is. A, the number in front of x squared is 2. B, the number in front of x, negative 7. And C, the number in front, or sorry, the constant, I should say. It would be in front of x to the 0 power, but if you just think of it as a constant, it would be 6. Okay, maybe you go ahead and try this yourself. See if you can fill in quadratic formula and show your steps for solving for x. All right, so x would equal, the opposite of b would be positive 7 plus or minus the square root of. I'm going to write the notation so that we don't mess it up. I'm going to have b squared, so it's negative 7 in parentheses squared, minus 4 times a of 2 times c of 6 all over 2 times a of 2. Okay, so starting to simplify then, 7 plus or minus. Your very first number in here, since it is squared, better be positive. Okay, so if you're ever get a negative there, you've got an issue. And then -4 times a positive is going to be negative. I just decide that first. 4 times 2, 8 times 6, 48. Okay, and then all over 4. Okay, so relating it back to what we were saying, inside the discriminant, you're going to get 1, right? So if it's positive, you should be getting 2 distinct solutions. Let's see if we do. This would be 7 plus or minus the square root of 1. Okay, so notice this is the square root of 1 right here. And so I'm just going to save myself a step. Square root of 1 is 1 all over 4. Never stop there, like we said before. Do the math yourself. So for instance, 7 minus 1 is 6. 6 over 4 reduces to 3/2. 7 plus 1 is 8, and 8 divided by 4 is 2. All right, so we did indeed get 2 distinct answers, which is what we would expect for a quadratic with the highest power being 2. Okay, that would be what's happening there. Next. All right, this one. Well, guys, you can't ever start, just like you can't factor, you can't use the quadratic formula, you can't do anything until this is set equal to 0. And of course, you always want to move it to the side where the squared term is positive. Okay, so I'll leave the x squared here, minus 6x minus 8 equals 0. If you want to go about it yourself, go ahead. I'm getting a is 1, b is -6, c is -8. So x will equal the opposite of b, so positive 6, plus or minus the square root of b, which is -6 squared, minus 4 times 1, which is a, times c, which is -8, all over 2 times a of 1. So x equals 6 plus or minus. First number better be positive. 36. Negative times negative with the -4, 1, and -8 is going to be positive. And then I'll get 32 in here, all over 2. Okay. And then at this point, go ahead and make that the square root of 68. And either do your perfect squares, your factor tree, whatever you're fast at now to try to break that down. Okay. And so this would be 6 plus or minus, well, 4 goes into 68 17 times. So this is really square root of 4 times the square root of 17. All right, so 2 root 17. That does not break down any further, over 2. Now at this point, most people can get here. At this point, you should be thinking, what can I reduce by? And when we reduce, if it can be reduced, okay, then you should be looking at these 3 numbers that I'm circling, the 6, the 2, and the 2, and seeing if they can all reduce by the same number. And indeed they can. They can all be reduced by 2. So 6 divided by 2 is 3. Plus or minus, we don't ever write a 1 in front of a root, nor do we ever write over 1. Okay. Now, based on our discriminant being positive up above, do we have 2 distinct answers? Yeah, 3 minus root 17 and 3 plus root 17. So I am happy with that result. Number 3, try it for yourself. A is 4, B is -4, C is 1. So x equals 4, right, the opposite of B, positive 4 plus or minus the square root of -4 squared minus 4 times a of 4 times c of 1 all over 2 times a of 4. So x equals 4 plus or minus, front number better always be positive, 16. -4 times 4 is going to give us -16 all over 8. All right, so we're getting 4 plus or minus. Now, the discriminant equals 0 is supposed to tell us one repeated solution. Well, let's see what happens. I'd have 4 plus or minus 0 over 8. And therefore, I am going to get 4 plus 0, or 4 minus 0 is still 4, over 8 is going to be 4/8, which reduces to 1/2. Now, don't forget, though, you need to account for the fact that this is a quadratic. So what that means to you is whether you do 4 plus 0 or 4 minus 0, you're getting that same answer twice. So you just say that it's a double root. We just write capital DR, okay? And I think I can convince you of this. If you were, I'm forcing you today, right, to use the quadratic formula because that's what I'm teaching you. I'm not giving you a choice. But I'm hoping the first thing you would always do if you were given a choice and nobody forced you to use quadratic formula, I hope the first thing you would always do is factor. Factoring should be faster than quadratic formula, okay? So if we had factored this thing at the start, if we had factored this guy at the start, wouldn't this have factored into 2x minus 1 and 2x minus 1? 2x minus 1 quantity squared? So if you set each factor equal to 0, wouldn't you get x equals 1/2 twice? Okay, so that should help convince you that, yes, you do get 1/2 twice. Okay. And then one more here. Okay, if you want to try it yourself. A equals 1, B equals -2, C equals 5. All right, so x equals the opposite of b, so +2, plus or minus the square root of b squared. So -2 squared minus 4 times a of 1 times c of 5 all over 2 times a of 1. Okay, so x equals 2 plus or minus the square root of, well, you know it's supposed to be a positive number, so 4. And negative times those positives will be negative. 4 times 1 times 5 is 20 all over 2. And don't stop there, please. Okay, so some of you can see what's going to happen, but I need you to finish the algebra so that I can check it on quizzes and tests and homework. So finish to this step at least for me. Get that this is going to be a square root of a -16. Okay, so we will just make a note here to keep going to this step. Keep going to this step. Okay, so I can grade that algebra. Then, of course, you're going to tell me, well, the discriminant being negative was supposed to mean no real solutions. Well, I think you would be convinced there. You can't take the square root of a negative number, and therefore no solution is your answer. Make sure you've got that written correctly, or you're welcome to always just write no real solutions in words. Okay. All right, and the last method we're going to look at for solving is that graphing calculator. Okay, so quadratic equations can be graphed on the calculator to find the solutions. Let's chat about where you'll find the solutions on the graph. Okay, so please know we're talking about, let's just make this up. So we're talking about quadratics, right? So quadratics graph into parabolas. So let's just say that's our xy axis and that I just drew this parabola. Okay. And where are our solutions? Well, remember, all of our equations are set equal to 0, right, before we ever do anything. So you're really kind of looking at this and saying, where's the y value? 0, right? You're solving for x when the y value is 0. Well, the y value is 0 on the x-axis. So you're really looking for these two places right there. Okay, you're looking for those two numbers. And those solutions, okay, those solutions will be the, well, they'll be the x-intercepts or zeros There's two other names that you need to know because we just kind of use them all interchangeable. So you need to know that x-intercepts, zeros, are also called solutions and roots. Okay, you've heard all of those in Algebra 1, okay, because they are all used a little bit differently, but you've heard that over and over, okay? So please make sure that you do know all four of those names. Okay, know all four. There we go. Okay, so we're going to, on a different time, we'll go ahead and go over graphing the examples from above, okay, those four above, and comparing the graph answers to the solutions that we obtained using the quadratic formula, because we definitely want to start making that connection, if you have not done so already, between what does the graph look like and what is the factoring or the quadratic formula. What is that really showing you? Okay, and it should be showing you those x-intercepts, zeros, solutions, roots, whatever you want to call them. Okay, so that will be continued.